ورحمة الله وصلى على محمد وعلى المقدم المكرم عندك يوم القيامة. So today we are going to study vectors, and we are going to start with the addition and subtraction of vectors in terms of their components and also in terms of the magnitude of a and b and the angle between the two vectors. If we are supposed to add two vectors, the addition of two vectors can be carried out by adding the corresponding components. So if we have got two vectors, a is equal to I plus 3j plus 4k, and we have got another vector I plus j plus 2k, the two vectors can be added by adding the corresponding components. That's, we will add the x component with the x component, y component with the y component, and z component with the z component. So in this case, a plus b we will obtain as 3i plus 4j plus 6k. That's how we added the corresponding components. Now if we are supposed to find the magnitude of a plus b, that can be found by the formula, that is root of the x component square plus y component square plus z component square. And in this case, the x component is 3, so it will be 3 square plus 4 square plus 6 square. 3 square is 9, 4 square is 16, and 36 is the square of 6. So that's root 61. Similar is the case with the subtraction of two vectors in terms of components. Subtraction of two vectors can be carried out by subtracting the corresponding components, as we did in the case of addition. So if we have got two vectors, a is equal to I plus 3j plus 4k, b is equal to I plus 2j plus 3k, then the two vectors can be subtracted by subtracting the corresponding components, in which the result will be I plus j plus k. Then we can also find the magnitude of the subtraction of two vectors, as magnitude of a minus b is equal to root of x component square plus y component square plus z component square. So it will be 1 square plus 1 square plus 1 square, that is root of 3. Then we have got the pictorial representation of the addition of vectors and the subtraction of vectors. In addition of vectors, if we have a vector a and we have other vector b, then using parallelogram law of vectors, the sum of two vectors will be equal to the diagonal of the parallelogram if completed. So this r will be equal to a plus b, and this can be obtained as follows. But if we want to find a minus b, we know of a concept that is known as negative vector. If we have got b as this vector, then minus b will be this vector, which will be completely in the opposite direction of the b, and it will have the same magnitude as that of b. Then a minus b can be formed. This is vector a, this is vector b. Then a plus minus b will be this vector, that will be the diagonal of the parallelogram formed in the below direction, and its magnitude will be equal to the root of a square plus minus b, that is again b, because the magnitude of b will be same as that of minus b. Say a square plus b square plus 2ab into cos of the angle between a and minus b. If the angle between a and b is theta, then the angle between a and minus b will be 180 minus theta. Because when the sum of two angles is 180 degree, if one angle is theta, then the other angle will be 180 minus theta. So cos of 180 minus theta is minus cos theta, so the resultant will be root of a square plus b square minus 2ab cos theta. Thus, if I have two vectors a and b, and we are supposed to find the magnitude of a minus b, how can we find that? If we know the magnitude of a, we know the magnitude of b, and we also know the angle between a and b. The magnitude of a minus b, that's r dash, the magnitude of a minus b in terms of the magnitude of the corresponding components, that is the resultant, that's the components in which it can be resolved, that will be root of a square plus b square minus 2ab cos theta. So this is actually the magnitude of a minus b. That's how much? Root of a square plus b square minus 2ab cos theta. Then we have got one more thing. Two vectors are multiplied. Two vectors are multiplied by two ways. Two vectors can be multiplied by two ways. Two vectors can be multiplied by two ways. One is by the scalar product or dot product, and second is the vector product or the cross product. Scalar product, the result obtained by this product is a scalar quantity, that's why it's known as scalar product. A dot b is equal to dot product or scalar product, because we replaced by dot. A dot b, that's a dot product or scalar product of two vectors, is equal to the magnitude of vector a into magnitude of vector b into cos of the angle between a and b. Now theta is the angle between two vectors, so that is how you can find the scalar product between two vectors in terms of the magnitude of the vectors and angle between two. This is all for today. We will meet again tomorrow.